Okay.
Good evening, sir.
Good evening. Okay. Good evening, everyone. So, what we were discussing yesterday, we were discussing the sodium chloride structure, right? So, we have completed till the atomic packing fraction, and we got the expression right there. So, today's task, first, we will discuss something about the sodium chloride, and then we'll move towards the hexagonal closed pack. So let's find out the nearest neighbor distance, coordination number, and second nearest neighbor for the sodium chloride. Okay. So let's start with the nearest neighbor distance. So what will be the nearest neighbor distance for the sodium chloride?
A/2.
Nearest neighbor distance. So nearest neighbor distance will be A/2. Okay. A/2. And how many nearest neighbor will be? How many nearest neighbor will be?
6.
6, obviously. It will follow the same symmetry as we discussed in the simple cubic, in the PCC-FCC. It will follow the same symmetry. Coordinates will be also same. What will be the coordinate? A/2, 0, 0, 0 A/2, 0, 0, 0 A/2. And similar, next will be from negative sides. Right? So, the distance will be A/2 and the number of nearest neighbor will be 6. So, this is the coordination number also. This is also the coordination number. This is also the coordination number. Okay, so write down everyone the first line, just because there's something, because in the means after discussing discussing this, I will tell you while taking means while interchanging the position of the ions. Okay, because many times the question in the exam the question has been asked in a different way. That's why I want you guys to write all the things means thoroughly on your notebook. Just write down. Just write down. Just mention a note that in a bracket Cl minus as a reference. In this figure, you are taking chlorine as a reference, right? Just mention there Cl minus as a reference in a bracket, and then write down the first point as I am conveying. There are 6 Na plus ions. There are 6 Na plus ions to Cl minus ions. There are 6 Na plus ion to the Cl minus ion, and put the Cl minus ion as a reference. Okay, at a distance A/2, at a distance A/2, right? Okay, understood?
Yes, sir.
Yes. So this is about the nearest neighbor. What will be the second nearest neighbor? What will be the second nearest neighbor? See, first see the statement. What you have written. There are 6 Na plus ions. There are 6 Na plus ion means when you are taking Cl minus as a reference, then their opposite ion, that is Na plus ion, will be the nearest neighbor. Okay, but what will be the second nearest neighbor? Anyone? What will be the second nearest neighbor when you are taking this chlorine as a reference?
Chlorine only.
Root 2 are, sir.
Atoms.
Root 2a distance. Okay, the
Yes, sir.
chlorine present at a root 2a distance, right? Right? या और भी कुछ होगा? Yes, exactly. There's also chlorine present at the A/√2 distance also. So while skipping A/√2, how can you go to the root 2a? Okay. See, first candidate is this at the distance A/2. Okay. Again, I'm mentioning with a number here. This is first. This is second. Okay. And let's suppose what? This is third will be some here. Third and fourth and so on. Okay. So First is at a distance a by 2. Second at a distance a by root 2. We'll see for the third nearest neighbor. So what will be the second nearest neighbor to this chlorine? Chlorine ions at a distance a by root 2, right? So the second nearest neighbor will be second nearest neighbor will be Cl minus ion at a distance a by root 2. At a distance a by root 2. And how many Cl minus will be there as a second
12.
nearest?
6.
Yes,
12, sir.
12.
12, sir.
12.
6.
6. Why 6? Yesterday I have discussed with the coordinate. Just remember the FCC lattice. I have write down all the 12 coordinates here. Okay. Yesterday we have written all the 12 coordinates. How a by root 2? ठीक है ना? The nearest neighbor of the FCC lattice. What was the nearest neighbor of the FCC lattice? A by root 2.
Yes, sir.
A by
Yes,
root
sir.
2 was there, na? And then I have written all the 12 coordinates and the same symmetry the following. Is following the same symmetry, na? So the second nearest neighbor will be Cl minus at a distance a by root 2. And how many Cl minus as a second nearest will be? It will be 12.
12.
Okay. Write down your statement on your notebook. Just give the heading as a second nearest neighbor. I am writing down, means I am saying this to write down you guys because this is quite important. Okay. Write down. There are 12 Cl minus ion. There are 12 Cl minus ion as second nearest neighbor. There are 12 Cl minus ion as second nearest neighbor to the Cl minus ion, which is our reference ion, right? At a distance a by root 2. At a distance a by root 2. Okay, don't get confused. Nearest neighbor
Sir,
will...
can you repeat once more?
Sir, please repeat.
Yes, yes. There are 12 Cl minus ion as a second nearest neighbor. There are 12 Cl minus ion as a second nearest neighbor to the Cl minus ion. And that Cl minus is our reference ion, right? Don't get confused. Nearest neighbor will be opposite ion. Second will be the same ion. Right?
Yes,
Right?
sir.
Yes. Now, what about the third nearest neighbor?
3/2 और Na होगा atom.
Yes, exactly. Everyone is convinced?
Yes, sir.
What will be the third nearest neighbor? Third nearest neighbor distance. Third nearest neighbor distance. What will be this distance? Under root 3a by 2. Okay. Which one? Which one? This one. This sodium ion. This sodium ion, which is present at the body center. So what will be this distance? Half of the body diagonal. The distance of body diagonal is root 3a. So half of the body diagonal is under root 3a by 2. Okay. So the third nearest neighbor distance will be the under root 3a by 2. And number of third nearest neighbor will be how much? How many?
8, sir.
8.
8. Just remember the nearest neighbor of BCC. Right? He is following the same symmetry. Number of third nearest neighbor. And this will be 8. If anyone is confused regarding the coordinates, tell me. I can write it down again. If every student have taken the class of body-centered cubic lattice, then the nearest neighbor of body-centered cubic was at the distance under root 3a by 2. There I have mentioned all the coordinates, right? Okay.
Yes, sir.
Yes, sir.
Yes. If anyone is confused or didn't remember that what will the coordinate of this point, I can write down again. Otherwise,
We'll once refer and then we'll ask you in the WhatsApp.
okay, fair enough. So write down the third statement. Write down the third statement. Given the heading, third nearest neighbor. Okay, there are 8 Na plus ion. There are 8 Na plus ion as a third nearest neighbor. There are 8 Na plus ion as a third nearest neighbor of Cl minus ion. Cl minus ion means reference ion. At a distance under root 3 by 2a. Under root 3 by 2a. Clear? Clear hai?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So this was all about when we have taken this structure. This structure means when chlorine at the corner and the faces and sodium at the edges and body center. But if we change the symmetry, means if we interchange the ions, just put the Na plus ion at the place of Cl minus and Cl minus ion at the place of Na plus ion. So I told you yesterday, then there will be no difference in the symmetry, right? So
Yes.
just write down or take it as a homework, just write down all three statement again by interchanging the Cl minus and Na plus. What I have told you, I have taken the Cl minus as a reference. This is your homework. Just take a Na plus ion as a reference ion, okay? And take what and just see the what will the nearest neighbor, second and third nearest neighbor. It will be exactly same at a distance point of view and the number point of view. It will just interchange the ion's name, okay? Because in exam they can ask, right? Like I have sent you a question. I will solve this after this means discussion. We'll solve this. You can see there, okay? There they have asked about the second nearest neighbor ion for the Na plus ion in a NaCl lattice. So in upcoming exam, they can ask about the, okay, just tell me what will the second nearest neighbor ion for the Cl minus ion. So number will be 12. Okay, don't get confused. Okay, so first, yes, any
सर
question?
आपने होमवर्क में क्या दिया ये सुन नहीं पाए हम एक बार दोबारा से बता दीजिए
No, it's just a very simple thing. I am saying I have taken this diagram. This diagram means Cl minus I have taken as a reference point, which is present at the corner and at the faces, and Na plus ion at the edges and the body centered. And I have write down, you have write down all the three statements regarding the nearest neighbor, second and third nearest neighbor. I am saying this is your homework, that just draw the picture, take the sodium at the corner and at the faces, and chlorine at the edges and the body center, just like interchanging the ions, and write down again all the three statements for the nearest neighbor. Okay,
ओके सर
because
ओके
because by this process I know this is means quite understandable, that if we understood, okay, if this is while interchanging there's no effect on symmetry, but still do not get confused before your exam time when you'll revise that. That's why this process is quite good. Just write down all the statement thoroughly. Okay. Okay.
Okay, sir.
Yes. So before switching to hexagonal close pack, let's solve some question I have sent you before starting of this class. Before starting of this class. Yes. First question is from IIT-JAM 2015. Which of the following statement is correct for NaCl crystal structure? Everyone, please see the question. Which of the following statement is correct for the NaCl crystal?
So option D.
Option D. It is a face-centered cubic with 2 atom bases. Right? Everyone is agreed?
Yes, sir.
Yes, sir.
Good. See the second question. The number of second nearest neighbor ion to Na plus ion in a NaCl crystal.
12.
12. Abhi bataya maine. Just told you before this. Second nearest neighbor. See, that's what I am telling. In this question, they have asked the number of second nearest neighbor ion to Na plus ion. But in upcoming exam, they can also ask the nearest neighbor, second nearest neighbor ion to the Cl minus ion. Okay. That will also be 12. That's what I'm telling you. Just write down thoroughly everything. Okay, everyone? Everyone has done this, okay? 12
Yes,
Yes,
sir.
sir.
database question.
Yes, sir.
Yes, just see the third question, just 2015. That's what I'm telling you yesterday. Just write down everything. The total number of Na plus and Cl minus ion per unit cell of NaCl.
8.
8.
8, sir.
8.
8.
8. Option D.
Yes, exactly. 4 of Na plus, 4 of Cl minus. So total will be 8. Okay, and if they can ask, what will be the total number of NaCl molecule in a NaCl lattice?
4.
4.
Unit cell.
4.
Okay, that's what I'm telling. Don't get confused. Okay, just write down everything thoroughly. Okay.
Huh?
Yes.
So the statement you just said in the last, can you please repeat? I'll just note down one.
Okay.
Total number of
I just make you write down in the yesterday also. The total number of NaCl molecule, the total number of your total effective number of, it will be a correct statement. The total effective number of NaCl molecule in a NaCl crystal structure is 4. Okay.
Yes, sir. Thank you.
Yes. So let's switch it over to the hexagonal closed pack structure. And also I have given you a question regarding finding out the coordinates of third nearest neighbor in the FCC lattice. So a few guys have done this and sent me back, but not everyone. What? Has everyone attempted that or not?
Yes.
Yes, sir.
Okay,
Yes,
I'm not going to discuss all that thing because that's a quite mathematical. I will send you means a picture, and from that that thing will be clear. Okay, for those who have not done that. Okay, so let's start with the hexagonal closed pack structure. See, while discussing the Pravegaa lattice, I told you that hexagonal closed pack, that is SCP, what was the condition for the lattice parameters? What was the condition for the lattice parameters? If anyone remember, that is A is equals to B, not equal to C. Okay.
Yes, sir.
And what about the orientation?
Alpha is equals to beta is equals to
gamma equals
90
to
degree.
120
Gamma
Gamma is
120
equals to 120 degree.
Gamma is equals to 120 degree. Okay. And what is the angle of alpha? This is the angle between
B and C.
B and C. This is the angle between A and C. And this is the angle between A and B.
A and B.
Okay. So this is a quite basic thing for the hexagonal closed pack lattice. In this structure, this orientation will be going to follow. That the two sides will be equal and the third side will be not equal to earlier one. And if you talk about the orientation, this orientation will follow that alpha will be equal to beta, obviously perpendicular to each other 90 degree. And the third angle gamma will be 120 degree. I will show you here. Okay. So first of all, let's talk about some structure here. Okay, let's talk about the structure. See, I have made this structure completely, but one by one, while drawing all the parts, actually this complete unit cell consists of 3 parts. This is the first plane, this is the second plane, and this 3 atom at the third plane. So I will draw here and so that you can understand this clearly. Okay. First of all, I am making the upper one plane. See, just draw the hexagon here. Okay, I have drawn the hexagon here, and each corner of a hexagon contain 1 atom. Just put the atom at this lattice point. Okay. Okay. 1 atom will be present at the face also. 1 atom will be present at the face also. Okay. This is our this plane, first plane, upper one. Okay. Now, similarly, same plane will follow as a this plane. It is the same, a hexagon, and each lattice point contain one atom. Okay. And at the face, there's also a atom, also an atom present. And this is the third part of this structure. There will be a symmetrical plane also, which will contain 3 atoms. It will contain the 3 atoms. Okay. When you will join these 3 planes together, you will get this structure. Okay. Like this. Okay. And this is a basic, the means you can say skeleton of this structure. Now come to the points. This atom, which is present at the center of face, which is present at the face center, you can say. This atom will be at the same distance from this point for this atom, same distance as from this atom, same as from this atom, same as from this atom, from this and from this also. And that distance will be A, small a, that is a side of, means H length. Okay. So I have mentioned there also, side is A. So this distance, all this distance will be A. This distance will also A. This will be also A, 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 and A. Okay. And this atom will be in touch with all the 6 atoms which present at the corners. Understood this point? I am repeating again. I have just made a skeleton of HCP lattice. Then I have put the atoms at the lattice point. There are 6 edges, means 6 corners. I have put atom on each corners here, each, and one atom will be present at the face center. Okay, I am saying that these all atom will be at the equidistance from this center face centered atom, and the distance will be A. And again, I am saying all these atom will be in touch with this atom. And similar symmetry will be follow in this plane also. This distance will be A, this distance will also be A, this will also be A, this will also be A, and this is also A. Right? Understood? So
Yes, sir.
we have talked about these 2 planes. Now let's talk about this one, this symmetrical plane. 3 atoms is there. 3 atom is there. Okay. Each atom are at the same distance, and same distance is A. Means distance between these 2 atoms will be A, distance between these 2 atoms will be A, and distance between these 2 atoms will also A. Okay. And one more thing. The distance of each atom from the upper basis and the lower basis. I'm saying again, just listen, this is quite interesting structure. Distance between this symmetrical plane atoms and this upper one plane atom will be identical. That is, each atom will be at a distance A. Here also, this atom from this will be at a distance A. It's quite interesting. From this distance is also A. This distance is also A. This will at also A, sare atom, all atom will be at the distance A, including the center one. I know it is quite difficult to visualize. That's why I have sent you 2 picture on your WhatsApp group. Just see that. Okay, and similar things will be follow here. Just see that picture. First one, you will understand completely. Everyone is seeing?
Yes, sir.
कुछ आइडिया लग रहा है क्या हो रहा है ये?
Yes, sir.
Okay. This is obviously quite interesting structure, but it is how it is.
Okay.
Okay. So all the distance will be equal and that will be at a distance A. And the height of this unit cell will be C. Height of this unit cell will be C. Okay. The height will be C. And the height means the center to center. Face center to face center atom separation. This is C. We'll find the value of C later on. Don't worry. Now, I have told you about the alpha, beta, and gamma. Let's think about that. Let's suppose, see, okay. Let's suppose this is our x-axis. Okay. Let's suppose this is our x-axis. This is our y-axis.
Sir,
Yes.
so you said about that ना कि जो फर्स्ट वाले फेज में है वो
हम्म।
सेंटर वाले पार्ट से ए डिस्टेंस में होगा, तो उसे अगर हम वर्बली
नहीं
लिखेंगे
नहीं
तो
नहीं 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 क्या एक बार फिर से बोलना, ये सेंटर टू सेंटर।
ये जो नो सर
हाँ।
वो जो उसका फर्स्ट फेज है और जो सेंटर में 3 एटम्स है वो सभी ए डिस्टेंसेस पर है, आपने यही कहा था ना?
यस एग्जैक्टली।
ओके
यस, डोंट वरी, अभी हम पूरी मैथमेटिक्स है इसमें, द होल कंप्लीट मैथमेटिक्स इज देयर इन दिस particular in this hexagonal closed pack. Everything will be clear, don't worry. Let's just complete this complete structure. You will get the answer of your every question. Okay, let's suppose this is x-axis, this is y-axis, and this is our z-axis. Okay, this is our, let's suppose this is our z-axis, z-cap direction, right? I have named this as, you can take any vector. I have named this as A vector, this as B vector, and this as C vector. This is vector and this is a height. Don't get confused. This is the height of the unit cell and this is just a vector. Okay. What I'm seeing, what I'm doing, what I'm trying to do here, I'm just want to tell you the alpha, beta, and gamma, how it will look like. That's what I'm doing here. See, what is the alpha? Angle between?
B bar and C bar.
90 degree.
No. There is the angle between what? B and
B
C.
and C. B and C, sir.
C.
Yes, exactly. That is this angle. Okay. This is your alpha. And what is this angle? This is 90 degree.
Yes, sir.
हो सकता है दिख नहीं रहा हो, maybe, but it is a 90 degree. This is something like that. Okay. This is a main plane and there is a z-axis. This is y-axis. This is x-axis. This is at a 90 degree. Beta.
फोन उसको बंद कर फोन
A and C, sir.
मतलब उसको डन
Beta is the angle between A and C.
A and C.
Okay. This will be our beta. This will also 90 degree.
That is also 90 degree.
Also 90 degree. Let's see about gamma. Gamma is the angle between A and B. This angle. Okay. This angle is gamma. And what will this angle? This angle will be 120 degree.
Yes, sir.
How? See. If you guys see here, while connecting all the lattice point together, you can see here there are total 6 triangle. Okay, there are total 6 triangle. Able to see? सबको दिख रहा है? There are total 6 triangle here, and they are equilateral triangle. And this angle for one triangle will be how much? 60 degree. And again, this is so the total angle will be 120 degree. Dikha? What we have discussed in the Pravegaa lattice, I have shown here. Okay, I have completely shown here. The angle between the means C and B is alpha, that is 90 degree. Angle between C and A is beta, is also 90 degree. And the angle between A and B, that is gamma, which is 120 degree. Clear?
Yes, sir.
Yes, sir.
Okay. Okay. Now,
तो सर
yes.
एक क्वेश्चन है
Hmm.
तो जब सारे ट्राइंगल से हम 60 के हैं
Hmm.
then one angle we are getting 120 and the two are 90.
Because this angle is made by this axis, z axis, and z axis is perpendicular this plane.
Okay.
So what will make this angle? This will be 90 degree, na?
90.
Okay. ठीक है ना? Can we assume this structure? Yes.
So it means that alpha and beta are the angle made by z-axis to the y and x-axis is
Alpha is the angle made by this z.
z-axis
Y.
and y-axis.
Yes.
And beta is the angle made by z-axis and x-axis.
Yes.
And gamma is the angle made by x and
Y.
y on the plane.
Yes.
Oh, okay, sir.
Okay. Now, I am going to rub this structure and will follow this one. Okay. And here we will find out our each information. So let's try. सबको figure समझ में आ गया? Everyone understood the figure?
Yes, sir.
Yes, sir.
Yes, sir.
There is a student from the Kerala named Apna. Is she present here? Is she present here in this class? Okay. Now, let's start with the effective number of atoms. Just try everyone. What will be the effective number of atoms?
8.
8. Effective number of atoms in an unit cell. Yes. 8, 6,
6.
Yes, sir.
6.
6. How? बता भी दो जल्दी से.
One atom is
atoms
shared by
shared by
6
six.
neighboring
So
atoms.
3 are in the body.
Okay. 3 at the body. ये तो simple आ गया. Good. And
3 are on the face.
तो 12 जो है वो कॉर्नर पे है तो 1/3 into 12 आएगा प्लस 1/2 into 2 आ जाएगा फेस पे प्लस 3 बॉडी में आ जाएगा.
good. See. 3 at the body center means at the mean symmetrical plane. That will completely 3 here. Okay. I'm rubbing it again and writing down. Okay. 3 plus 1 and 1. 2. 2 atom present at the face. And face is shared by
1/2.
2 cell.
Yes, sir.
That is 2 multiplied by 1/2. Now, how many atoms are present at the corners?
12.
12
12.
atoms.
12.
Yes, sir.
3, 3, 6, 3, 9, 3, 12. Anyone has confusion? 12. And one atom will be shared by how many cells?
6.
3.
1 by 6.
6.
1 by 2.
Okay. So this will be 3 plus 1 plus 2. And that will be 6. So the N effective will be 6 for the hexagonal closed pack. Okay, just write down completely in the big bracket N effective equal to 6.
Corner
For
का
this. हाँ
6 atoms से कैसे share होगा?
नहीं 6 के साथ शेयर होगा. One atom will be shared by the 6 cells. आप देखना थोड़ा सिमेट्री उसका विजुलाइज करने की कोशिश करना.
Okay.
Okay. 6 cells इसके साथ शेयर होगा. Don't worry. Now, what was our next task?
Radius, sir.
Area.
Radius.
Radius. Yes. And effective, just I'm writing down effective is 6. Radius, R versus A relation. Okay. So, same procedure, what we have done in the some last classes. Considering as reference atom, I am considering this as our reference atom. Why I'm considering this? You can take anyone, but if you guys also take this as a reference atom, you can visualize all the symmetry easily. Otherwise, if you get this one or this one, there will be more trouble. Okay. I'm taking this atom as our reference atom. So search out for the nearest neighbor. What will be the nearest neighbor?
A पे ही आएगा.
A distance पर ही आएगा. The atom will present at the distance A. So I have taken this atom and taken this atom, making a biggest sphere. This radius is, let's suppose R. This suppose radius is R, and the center to center separation is A. So that will be 2R is equals to A and R is equals to A by 2. Clear?
Yes, sir.
Clear?
Yes, sir.
Okay. Now,
Sir, can we find here the relation between R and C?
I will find. Don't worry. Don't worry. We will find. See, there's a very, means you can say, important relation. The relation between the C and A. The relation between C and A. And this C by A ratio, it will be equal to root under 8 by 3. It will be root under 8 by 3. Consider this as your homework. Just derive this relation quite easy, just little bit geometry knowledge you need. If any guys not able to solve this derivation, I will solve tomorrow here. Don't worry, but try once just for the practice. No need of that derivation. Again, I'm saying, as your exam point of view, there's no need of this derivation. This relation, but is quite important, because one or two exams, different exams has asked simply this relation. Consider a hexagonal closed pack structure. Let's see the height of this unit cell. A is the length, wall be the ratio. 4 option is given. This relation is quite important. Just take this as homework. If you guys are able to find out, fine. Otherwise, tomorrow I will solve here completely. Okay?
Okay, sir.
Yes.
Yes, sir.
Sorry. So the C by E ratio is under root A by 3. Now, our next task. I'm not going in this derivation because quite means it's time taking and there's no need. But still, see, listen. If any guy is facing problem while deriving this relation, I will solve tomorrow. Don't worry for that. Okay? Just try once. Now, next task is to find out the what?
Atomic fraction.
Atomic packing fraction.
Atomic packing fraction.
But before that, we need to find the volume of unit cell, right? Because in the atomic packing fraction, in the numerator, there is an N effective multiplied the volume of one atom divided by the volume of unit cell, right?
Yes, sir.
So for deriving the atomic packing fraction, first we need to find the volume of the unit cell. Let's find out. Volume of the unit cell. Okay, let's see. Volume, that is area of base multiplied by the height, right? यही होता है ना? Area of base multiplied by the height. Height is already given, that is C. Height is given as C. Find the area of base.
6 into area of one equilateral triangle.
Area of base. Yes, exactly. You are right. Everyone see this plane or this plane. Both are same. Considering this as your base area, if we have to find the area of this complete base, what will be this area? what your people are able to see here, I have already told you there is 6 triangle.
Triangles, yes, sir.
Yes,
Yes,
sir.
sir.
There's 6 triangle, and the side is A. Side is A. So
Root 3 a square.
what will be the area of triangle for the equilateral triangle? What is the area?
By 2 side square.
Sorry,
Root 3 by 4 a square.
root 3 by 4 side square. Yes. So root 3 by 4, and the side is A, that is A square. And there's how many triangles are there? 6 triangles. They're simple multiplied by the 6. Okay. So this is of area of base. This is your height. Now we can get volume of the unit cell easily. So the volume will be what? 6 into under root 3 by 4 A square and height, that is C. Right? Just simplify this. What will be? 2, 3. That is 3 root 3 by 2 A square C. Remember the discussion of Bravais lattice? What was the volume of the unit cell for the hexagonal close pack? 3 root 3 by 2 A square C. Aaya tha?
Yes,
Yes,
sir.
sir.
Yes. Now, this is first relation. Let's suppose we know one more relation from this, that is C by A is root of 8 by 3. This is a complete root, okay? This is a complete root over 8 by 3. Sometimes in an exam, they can ask the volume in terms of lattice parameter, means edge length only. So nothing to worry about. Just put the value of C in terms of A from here. So what will be the value? What will the volume? The V is equals to 3 under root 3 by 2. Okay. A square multiplied by the C value will be root 8 by 3 multiplied by A. यही होगा? Okay.
Yes.
Just simplify this again.
3 root 2.
Root 3 will be cancelled out.
Yes,
8
sir.
will become 2 root 2.
Yes,
Yes.
sir.
2 will also be cancelled out.
Yes, sir. 3 root.
And their volume will be
3 root 2 a
root
cube.
2 A cube. This is your second relation, volume of the unit cell. Now, any guy was asking the relation between volume in terms of R, right? Nothing to do. Put the value of A in terms of R. What we have found? R is equals to A by 2. Put
Yes,
the value
sir.
of A. A is equals to 2R. Put the value of A is equals to 2R here. This will become how much? This will become, volume will be equal to 2 to the 4, 8. 24 root 2 and R cube. Right? Correct? This is your third relation. Okay, so all three are the volume of the unit cell, but in the different manner. This is completely in terms of A, that is edge length. This is in terms of A and C, quite famous, quite important. And this in terms of R. Okay, so all R3 are important. Okay, now let's find out the atomic packing fraction. Let's find out the atomic packing fraction. What was the N effective here? N effective was 6.
Yes, sir.
Okay, and the volume is, we have got 3 root 2 A cube, 3 root 3 by 2 A square C, and obviously 24 root 2 R cube. Okay, just use this and find the atomic packing fraction. Find out, everyone. Find out.
74.
Obviously, it is quite famous, but let's find out. N effective multiplied by the volume of one atom, 4 by 3 pi R cube, divided by the volume of unit cell. Volume of unit cell. Just put all the value and find out, everyone. 6, change R in terms of A or whatever you want to do. Means numerator and denominator will be cancelled out. And when you will solve this, you will get atomic packing fraction at 0.74.
24%.
0.74, or in terms of percentage, it will be 74%. That means it is tightly packed structure. This is tightly packed structure. Understood? This is tightly packed structure. What is the example? Anyone knows? Example of SCP structure. You know, it's a magnesium, titanium, many are there. Magnesium is a quite famous example of an HCP structure. Okay?
सर FCC का एग्जांपल क्या है?
FCC का एग्जांपल क्या है बताओ, आप ही बताओ. NaCl पढ़कर हम लोग आ रहे हैं. सोडियम.
कॉपर भी हो सकता है.
सोडियम.
सोडियम है, हाँ, दो बहुत से हैं. सोडियम इज आल्सो FCC स्ट्रक्चर.
सर डायमंड.
सर HCP का क्या बोला? मैग्नीशियम क्रिस्टल.
Magnesium, titanium, etc.
Okay.
Many are there. Okay. Now, we have time actually for 10 minutes.
तो जब हम एटॉमिक पैकिंग फ्रैक्शन फाइंड करेंगे तो जो नीचे वॉल्यूम ऑफ यूनिट सेल है, जैसे हमें 3 जो वॉल्यूम है यूनिट सेल की ये गिवन है, इनमें से हमें कौन सी वॉल्यूम लेनी है?
आप अपने अनुसार ले सकते हो. You can take as your choice. Whatever you will
Okay.
take, the variable from numerator and denominator have to cancel out. If you change
Okay.
R in terms of A, that will also cancel out. Okay.
जी.
At the
जी,
last, what you get? You get the numbers, na? Variable will be cancelled out. So you can take any volume, will be cancelled out. Means variable will be
Thank you,
cancelled
sir.
out. Okay. 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 So tell me, nearest neighbor distance. Nearest neighbor
A
distance.
by 2.
A by 2
A.
सर.
Huh? A by
A
2.
by 2 सर.
A by 2.
A.
Yes, sir.
A.
A obviously. Yes. Nearest neighbor will be A. And how many nearest neighbor will be?
6.
How many?
12.
6.
Huh?
12 सर.
12.
12. How? सबको पता है ना 12 कैसे? सबको दिख रहा है?
Yes sir.
6, 3, 9 and 3 from upper one. भाई 3 इसके ऊपर भी तो हो गया ना, बिल्कुल सेम इसे. Okay.
Yes, sir.
Okay. When
Yes,
you will expand in the complete infinite extension, it will be quite easy to visualize. Okay. So there will be total 12 nearest neighbors. So the coordination number is coordination number is 12. Coordination number is 12. Now, I am giving you some good tasks for your homework. The homework is find out the second nearest neighbor distance and third nearest neighbor distance for this lattice. Okay, so from this you will get some practice finding out the, because in the for the exam point of view, obviously you have to learn all that means data chart. I told you already. So this is for your practice. Just find out the second nearest neighbor distance and how many there will be second nearest neighbor. Also find the third nearest neighbor distance and also tell the how many third nearest neighbor will be there. Consider this as your reference, because I told you if you take any other reference point, you will get in trouble. Okay, just take this as your reference and let's find out. Okay, and tell me on your WhatsApp. Let's see how much it will come. Okay.
Yes, sir.
And after getting the second nearest neighbor and third nearest neighbor, the hexagonal close packed lattice will be over. And also C by A ratio ka derivation kar lena. Please complete the derivation of C by A ratio. This is for your sake of practice. Okay, I will do if anyone gets in trouble while deriving that. See, in book it is given. In book it is quite easily it is given. There's some geometry, complicated geometry is there still, but it is given. So don't take from that means book. Just try it by yourself. If you are not able to do, I will do here in class. Okay.
Yes, sir.
Okay. So after discussing all the homework tomorrow, we will start the diamond cubic lattice. Okay. Any question?
Yes, sir.
Any
No,
question?
sir.
Okay. Okay. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you sir.
Thank you, sir.